Good day, Ms. Escabel. We are from Bachelor Forensic Science 1A, and we are going to talk about forensic engineering. So my group mates are GAPASIN Carlo, Verdadero Herbert, and yours truly, Canobar Aliana Joy. So we have four contents under forensic engineering, tackling first, the short history. Second would be the relevance to investigation and court. Under this, we have the evidence to present, techniques in examination, and then the third content would be too important or celebrated case involvement. So as for the last content would be the basic equipments used.
So I'm Herbert Joshua Verdadero, and today I'm going to discuss a short history or a background regarding forensic engineering. So a famous quote is that forensic engineering has been defined as an investigation of failures. So forensic engineering is the investigation of property loss and injuries related to failure in materials, components, design, and structures. This can be minor incidents such as a crankshaft breaking or even catastrophic events such as a bridge collapse. It is also worth noting that it is now a growing field in the Philippines as it involves the application of engineering and principles in performing a failure analysis of a certain product, machine, structure, or process. And it looks into the components, design, and installation of materials. So one of the most common applications of forensic engineering is in the decoding of product liability. Claimants or plaintiffs and defendants both rely on expert testimony to establish a chain of events and apportion who is at fault. So in here are a few different examples. So where forensic engineers are being called to investigate. So the first one is a concert stage collapsing and crushing a person underneath before the show, an electric kettle experiencing an electrical failure and causing burns to the owner, and lastly, a bridge collapsing under the weight of snow and ice despite being deemed safe.
This is GRP2, and I will talk about relevance to investigation and court. A. Evidence to present techniques. B. And techniques in examination. Forensics, forensic investigation has been a part of the resolution process in civil and criminal trials, insurance claims, contractual disputes, and more. Extensive and in-depth investigation helps to identify problems and finding empower engineers and manufacturers, builders to avoid these mistakes in the future.
So here are a few ways forensic engineering helps resolve disputes and make the world safer. So first is forensic engineers can provide expert testimony that helps the court understand the technical issues. They can give definitive findings that enable claims adjusters and assessors to determine the compensation. They can help make components and machine parts safer. They can reduce the failure rates in auto applications. They can improve the procedures to reduce manufacturing or building imperfections. They can share technical information of failures and build the knowledge based on it. And lastly, they can develop or even improve guidelines on conducting the failure investigations. So there's really no definitive list on the types of accidents that forensic engineers can investigate. A forensic team may work with commercial and industrial clients, even with government regulators, and even health and safety bodies to decipher the complex causes behind accidents. So here are a few examples. A biomechanical and bodily injury, fires and building codes, structural and civil failures, reconstructing collisions, environmental disaster investigations, electrical failures and fires, geotechnical investigations, product failures, material failures, and lastly, transportation and trucking accidents. Forensic engineering is defined as a multidisciplinary practice that includes evidence gathering, failure analysis, simulation, accelerated life testing, and statistical analysis. So it is important that a forensic engineer must possess considerable knowledge in the specific field of engineering. And the role of a forensic engineer can be divided into three distinct phases. The first one is the gathering of evidence, investigation analysis, and reporting to the client. And further details will be discussed on the next slides po by Eliana. Thank you.
So I'm Aliana Joy Canobar. So we will now discuss the three role of the forensic engineer in different phases. So these are the techniques needed for forensic engineering cases. So first one would be gathering evidence. As for gathering evidence, researching the background of the incident, knowing what happened, how it happened, and what specific case does the scenario looks like. Now, the next one would be the organization on site. And the third one would be ensuring proper scene preservation. This is very much important in gathering evidence because you cannot know what is really needed or what is really important in the case if you will not preserve the scene itself. The fourth one would be assessment of hazards. Siyempre, safety first pa rin tayo. We must know when and how to gather those evidences without harming the investigator or even the forensic engineer themselves. So next one would be directing evidence gathering. So as for the next slide would be the investigation analysis. So this is the process itself, the system of how will you investigate the incident, the scene. So first is initial appraisal of incident. Second one, understand terms of reference provided by client. Since this is forensic engineering more on infrastructures and buildings, so you must know the terms needed for the case. Next one, to plan out investigation. And again, this is infrastructure and building. You must have a plan in order to lessen the casualties and at the same time to preserve the evidence needed for the case. So form investigation team. We really need to form an investigation team because one cannot solve the case itself themselves. So next one would be determine extent of investigation based on terms of reference. Next is avoid bias and maintain objectivity. Again, this is a case that must be solved, so we must always look for the truth, look for what is behind the case and what really happened in the scenario. So next would be reporting to the client. So the nature and cause of failure. So we, as a forensic engineer, you must know how or why it collapsed or how a building was broken down into pieces. And next one would be expert testimony before the court or other forum. So as a forensic engineer, you are expert in that field. So your testimony will be very much valid in the court because you will testify with facts and proven data needed for the case. So as for the next content would be important or celebrated case involvement. Actually, we gave three cases that involves forensic engineering. So the history of forensic engineering includes the investigation of bridge failures in the past. So first is Thai bridge disaster, Ronan Point, the bridge disaster. So let me just add that these three disaster was happened before, happened in the past already, very much late in the past. So first one would be Thai bridge disaster. So one of the most notable examples of structural collapse in British construction history. In December 1879, the Tay Rail Bridge spanning the River Tay at Dundee, Scotland, failed dramatically as a locomotive was passing over its central span. So the entire train plunged into the river, killing all 75 75 people to be on board. So the investigation pointed to numerous cases that led to the disaster, including a 70 mph gale, poor manufacturing quality in some structural components, and inadequate site supervision. So even before, in the year of 1879, we have cases like this that was investigated by forensic engineering. Although forensic engineering was developed or improved in the present time or just lately, but then with these cases, forensic engineering is really needed to investigate how it happened, why it happened, and the casualties that was part of this accident. So next would be the Ronan point. So this tackles more on the building collapsing. So before we had a bridge that collapsed, now we had a building. We have a building. So in May 1969, Ronan Point, a 22-story residential tower block, suffered a catastrophic partial collapse only 2 months after it opened to council tenants. 4 people were killed and 17 injured. So a boiler explosion on the 18th floor that should have been contained by the construction led instead to the progressive collapse of one corner of the building. So the forensic investigation, which fed into the Griffiths inquiry, found that the method of wall support between floors was inadequate, and the ability of the construction to contain such a small blast was grossly inadequate, given the lack of injury to the person who lit the match in the fateful flat. So dito po makikita na natin kung gaano kahalaga yung forensic engineering. Kasi an investigator himself cannot investigate this kind of case without an expert's point of view, and that is a forensic engineer. Kasi po, we are tackling more on the buildings and infrastructures, the materials used for this, as what stated in the PowerPoint. 4 people were killed and 17 injured due to the inadequate ability of construction to contain such a small blast. So, hindi din malalaman yon ng simpleng investigador lang kung walang forensic engineer. So next one would be the D Bridge disaster. On 24 May 1847, the carriages of a local passenger train to Ruabon fell through the bridge into the river. So the accident resulted in 5 deaths, 3 passengers, the train guard, and the locomotive fireman, and 9 serious injuries. So the bridge had been designed by Robert Stephenson, and the local inquest accused him of negligence. Although strong in compression, cast iron was known to be brittle in tension or bending, yet the bridge deck was covered with track ballast on the day of the accident to prevent the oak beams supporting the track from catching fire. So as you can see, the scenario or the cases given was more on bridge, on casualties or accidents happened in the bridge, train, vehicles, because dito kasi madalas nakikita yung mga marurupok na gawa, yung mga hindi talaga napagplanuhan kung paano bubuuin. And then, again, an investigator himself, ang isang simpleng investigador ay hindi mahuhulaan kung ano yung nangyari sa infrastructure na yon, kung ano yung pwedeng ikaso sa mismong gumawa nung bridge na yon. Kasi alam naman nating lahat na ang engineer pwedeng matanggalan ng lisensya kapag may mali or may kulang or inadequate or hindi enough yung mga materials para mag-sustain ng isang infrastructure or ng isang building. So kung hindi siya tatatag, hindi magiging matatag, magiging marupok lang. And again, magkakaroon tayo ng casualties and accidents, deaths in the worst case scenario. Ayun po yung magiging way ng forensic engineer para pwede nating makasuhan yung mismong gumawa ng mga infrastructure na to. Although we are not giving them a hard time, but then we need to have someone who is responsible, kung sino yung aako ng responsibilidad and accountability for this accident.
Basic equipment used in forensic engineering. Faro, Faro, Faro 3D laser. The scanner produces photorealistic 3D image of real-world object or scene. It captures several million 3D coordinates and creates a three-dimensional impression. Ito po ay parang mas detalye po yung makikita po ng mga investigador na mas detalye po yung bagay na aksidente. X-ray machine. X-ray machine that can be used for non-destructive testing of failed components and tires. This equipment can also be used by our engineers and experts to identify hidden evidence in melted debris after a fire.
So the next one po is an infrared camera. An infrared camera is used to photograph walls, roofs, and other hidden areas within a structure with the purpose of identifying moisture, electrical, or temperature problems. Megometer. A megometer is used by our experts to measure the electrical resistance of insulators. This can be used to test electrical equipment and wiring after an electrical surge, lightning strike, or a flood. Roof scanners. Roof scanners that are designed for precise and non-destructive evaluation of moisture conditions and leak tracing in roofing and wall systems of a structure.
So I guess that would be the ending of our presentation. And I would like to add more na for you to become a forensic engineer, you should first be an expert in the field of engineering. Kasi po, as what I have read in different articles, for you to become a forensic engineer, you must first have a license as an engineer for you to become credible in identifying the materials used and materials needed for the investigation for you to become a forensic engineer. So I guess this will be the last part of our presentation, and we hope that we had supplied you enough information needed for the topic forensic engineering. Thank you po. Again, I am Aliana Joy Dial Canobar, and my group mates are Herbert Verdadero and Carlo GAPASIN. Thank you.